Hello and welcome. Today we're talking about exponents and exponential functions. I know it sounds like it's a lot, but let's start with the basics. What is an exponent? It's a quantity representing the power to which a number or expression can be raised. It's also called an index or power. So below we have some examples. So here's your base. Your base is going to be an x in this case right here. Your exponent, or it could be called an index or a power, is 5. So what this represents is x times x times x times x times x. How many times your base is being multiplied, okay? So if I give you a number example here, the 2 is your base. The exponent is going to be a 5, same thing. That's going to represent 2 times 2 times 2 times 2 times 2, all right? All right, guys, so in this exponent unit, what we're going to learn is that all these exponents have different properties, all right? And we're going to start with the first property today. This property is called the product of powers property. The example they give you have letters, have variables. So we have a to the m power times a to the n power. And what's going to equal is a to the m plus n, all right? That's a lot of mumbo jumbo right now, but let's look at our number example. Now, my printer's not the best, so I had to write it in. Let me tell you what this says. 5 to the 6th power times 5 to the 3rd equals 5 to the 6th plus 3. So you're adding your exponents here, and it's going to give you 5 to the 9th power. So what this whole property is telling you is that when you add, or when you multiply numbers that have the same base, you add your exponents. I like to think of it like this little jingle right here. When you have the same base and you multiply across, you add your exponents. So what I'm saying is the base is the same, the a is the same. You're multiplying across, so you're multiplying this times this. So you need to add your exponents. One more time, I'm going to say this one more time so we remember it. When you have the same base and you multiply across, you add your exponents. So it's a pretty simple property. It's the first one we're going to look at. All right, so with this first example here, we have 4 to the 7th times 4 to the 6th. So we're going to keep this exact same base, but we're going to add our exponents. I'm just showing that extra work here, but our true answer is going to be 4 to the 13th power. This is me showing the work here. For letter B, this is a little bit of a tricky one, because what you haven't seen is a variable or even a number in this case without an exponent. So we would assume, of course, that exponent is a 1. I like to write in the 1 so I don't forget that I have to add that along with my exponents. So I'm going to keep the exact same base, and I'm going to add my exponents. 5 plus 1 plus 2. So that's going to give me that same base of 8, but it's going to give me the 8th power. Let's look at my next example. Letter C. We have -4 on the outside, okay? There's nothing, the exponent is still a 1 here, but there's nothing for me to multiply that has the same base, okay? So we're going to keep that -4 there. Now, there's something different here. We have an x to the 3rd times x to the 8th times x. So we know that should get the exponent of 1 right there. Those are all the same bases, so I can add my exponents there. So I have x to the 3rd plus 8 plus 1. Okay, remember the -4 stays exactly the same. So -4 comes down, then I have x to the 12th when I add all those numbers together. Now, if there was something with the same base, we could multiply those and add our exponents, just like here. But there wasn't, so we're just going to keep it. For our last example, there's a similar number out front here, but there's no other numbers. So we're going to bring down our -2. All right, we have different variables here. Let's look for the ones that are similar. With my a here, I know that I have the exponent of 1. There's another a here, and that's all my a's. So I'm going to have a to the 1st power plus a, oh, I don't need to write that actually, excuse me, plus 3. All right, the a's are done. I'm just going to cross them off so they don't get in my way. Now I'm going to have the b's as well. In this case, this b has the power of 1, a 3 here, a 5 here, and a 2 here. So I'm going to bring that negative 2 down. When I simplify here, I'll have a to the 4th. Over here, I'll have 11, b to the 11th.